Hi guys, in this video we're going to be continuing with MLRM. So I'm actually going to start with the OLS derivations for multiple linear regression model. Now, as I mentioned in the previous video, I can write the MLRM model as the follows. So beta 1 plus beta 2 x2I So, as I said, under the OLS, you minimize the sum of squared errors, right? So you minimize summation EI squared basically. Now EI squared is EI is nothing but YI minus YI hat, right? So that is equal to summation I YI minus B1 minus B2 x2I minus B3 x3I, right? So this is just going to be now you differentiate this with respect to B1, B2 and B3. Why? Because we're taking the first order conditions, right? So this is nothing but your objective function and you have to minimize it with respect to B1, B2, B3. So minimize summation EI squared and this is with respect to B1, B2, B3 because these are the three choices you make. So del summation I EI squared by del B1 is nothing but minus 2 summation I YI minus B1 minus B2 x2I minus B3 x3I, right, which is equal to minus 2 summation I EI in fact. Second is del summation I EI squared by del B2 which is equal to minus 2 summation I YI minus B1 minus B2 x2I minus B3 x3I into x2I. This is going to be minus 2 summation I EI x2I, right? Similarly, del summation I EI squared by del B3 is going to be nothing but summation I minus 2 summation I EI x3I, right? Just like this one. Okay. Now, putting the FOC is equal to 0, right? So, when you put 1 equal to 0, what would you get? You would get summation I YI equals n B1 plus B2 summation I x2I plus B3 summation I x3I, right? Now I can divide this entire thing by n and I can say y bar equals B1 plus B2 x2 bar plus B3 x3 bar, right? So that's your equation 1. Now equation 2 is nothing but summation I x2I yi equals B1 summation I x2I plus B2 summation I x2I squared plus B3 summation I x2I x3I, right? Now the third equation can be written as summation I x3I yi equals B1 summation I x3I plus B2 summation I x2I x3I plus B3 summation I x3I squared, right? Okay, so these three equations are actually known as the normal equations, right? Now in fact this is the normal equation. This is just a sort of reduced form of the normal equation basically. So these three are your normal equations, right? And what you get from your normal equations is basically, there's the middle step to kind of getting to B1, B2 and B3. Even in the even in the single variable case, if you remember, we had the normal equations, right? And they looked very, very similar to what you have here. Again, if you can't see that, please go back, look at those videos again, right? All right. So now that you have your normal equations, the next thing that I would ask you to do, so these are 1, 2, 3. Let me call this 4, okay? Now you substitute 4 in 2 and then 3 respectively, okay? So what do you get? When you substitute 4 in 2, you have summation I x2i yi equals y bar minus b2 x2 bar minus b3 x3 bar summation I x2y plus b2 summation I x2i squared plus b3 summation I x3i, right? Now this can actually equivalently be written by as summation I x2i yi, right? And I'm just going to take this y bar over here. So basically minus summation I x2i y bar, because this is going to be multiplied by this when you take it to this side, right? Equals b2 summation I x2i squared minus x2 bar, right? Summation, so this is again summation I x2 bar basically minus b3 summation I x3i minus summation I x2i x3 bar. Okay, all right. Now the next thing to do here is actually, so I think I made one error here. This should be, yeah, summation I x3i x2i, right? So yeah, this is fine. So I have just substituted, right? If you're following this with your notebook and your pen and paper, basically you should be able to see that I've done nothing but substitute and then kind of move shift terms around a little bit. The only reason that I'm doing that is because I want to get to a point where I can combine something like x2y yi and x2y y bar, because if you look at this expression here, this can actually in fact, and I'm going to switch colors here to do this, this can in fact be written as summation I x2y, right, yi minus y bar, which is equivalently equal to summation I x2y minus x2 bar into yi minus y bar, right? Because recall that for any two x's and y's, I can write summation xi, so summation I xi minus x bar yi minus y bar can in fact be written as summation I xi minus x bar yi minus y bar summation I xi minus x bar, and then this is nothing but deviation from the mean, so it goes to 0, so which means that you are left with effectively only this, right? So this can be equivalently written as this for any x and y. For any x and y, I can say summation xi minus x bar into yi minus y bar equals summation xi minus x bar into yi, or summation yi minus y bar into xi equivalently, right? So because we can say this is why in fact saying something like this is all right. So let me just get rid of this extra stuff here. So let's just, yeah, okay. So now that you have all of this, right, so you have summation I x2y yi minus y bar, and you have it like this, right? Similarly, here also I can write this term in fact as follows: summation I x2i common x2y minus x2 bar, right? Again, this can equivalently be written as the summation I x2y minus x2 bar into x2y minus x2 bar, right? Similarly here, this term, again let me switch colors. So this term can in fact be written as summation I x2i x3i. So x2i common, right? And it will be x3i minus x3 bar, right? So this could be x2i minus x2 bar into x3i minus x3 bar, right? So using the same thing as described here. Now, what does this mean? So this is, you should be able to recognize that if I were indeed able to write this as x2y minus x2 bar, x3i minus x3 bar, this would be nothing but, you know, covariance between x2 and x3. This is variance of x2 or covariance between x2 and x2. And this is nothing but covariance between x2 and y, right? All right. Similarly, and this is, I mean, the only reason I'm kind of, you know, I want to kind of tell you that these are covariances is because once you start recognizing that, things start seeming a lot more, you know, familiar, because you're dealing with variances and covariances, right? So there's nothing to be worried about, just, you know, looking at all the math. All right. So now that you have this in your thing, if you substitute for basically, which is the value of B1 in the FOC for B3, then you will get a very similar expression for B3 as well. Now the point is that, you know, how I'm going to write this now is very important. So I am actually going to write this as follows, and this is where the only place where you will see me using this terminology, but I think for this particular derivation it's kind of important because I mean, it just becomes too confusing otherwise. So summation x2y yi, so this thing, right, I am just going to write this as summation I small x2y yi, okay? So summation small x2y yi equals equals, right? So this is equal to actually B2 into summation, so this would be B2, right, summation I x2i squared, right, plus and B3, or rather minus B3, I think, hold on, it's plus B3, right? So plus B3 into summation I x2i x3i, where each of these small x's is in fact x minus x bar respectively, right? So this is true for all x's, okay? I'm just going to get rid of this, but I mean, this should be logical. I've just called it a slightly different term, okay? All right. So this is your, let's just call it equation number 5, okay? And similarly, if you were to substitute 4 in 3, what you would get is as follows. So you would get summation I x3i yi equals B2 summation I x3i x2y, okay, plus B3 summation I x3i squared, okay? Now these are, so this is 5 and 6, right? Now these are two equations in two unknowns. So what are your unknowns here? Let's just try to identify that, okay? So B2 is an unknown, B3 is an unknown, and again B2 is an unknown, B3 is an unknown. This is equation 1, let's just call it, and this is equation 2. Now can I or can I not apply Cramer's rule here? I can, right? So Cramer's rule being applied, let's just first make the first, you know, delta, the first matrix, right? If you're not familiar with the Cramer's rule, I really cannot, you know, explain it here in the capacity of this video. My suggestion is to go to your MME2 syllabus and kind of, you know, take note from there. In case, you know, that is not feasible for you, please get back to us and, you know, we'll help you out. Alright, so I'm just going to apply the Cramer's rule here. You have two equations in two unknowns, and so I'm just going to make the first matrix, which is the base matrix. So this is going to be nothing but So with B2, so I have the columns for B2 and B3 here respectively, right? And I'm just going to fill these up. So let me just again switch colors here, right? So B2 would be nothing but summation I x2I squared, right? And here in the second equation it is summation I x3I x2I. Recall that, you know, small x's are nothing but capital X minus capital X bar. And then B3 has summation I x3I x2y, right, and summation I x3I squared. Okay, all right. Now delta 1 would be nothing but you replacing this with, you know, the constants. So that is just going to be summation I x2I yi, summation I x3I yi, right, and then summation I x3I x2y remain as is, and summation I x3I squared remain as is, right? Similarly, I can write delta 2 here. The reason that I'm sticking to one slide and not changing slides is because it's important that, you know, I mean, it's easier for me to kind of keep track, right? So this is just going to be summation I x2I squared, summation I x3I x2y. This is just, you know, a copy of this column, and now you have the constants replacing this. So summation I x2I yi, summation I x3I yi, right? So you have delta 2, delta 1 and delta. Now B2 is going to be, B2 is going to be nothing but delta 1 over delta. B3 is going to be nothing but delta 2 over delta, right? And that's just the determinant value, right? So okay, I'm going to leave that here, right? In your notes you will find the expressions for B2 and B3. In fact, you go ahead and go a step further and also find the expressions for the variances of B2 and B3. Again, my best suggestion with variances of B2 and B3 is that you remember them. Okay, memorize these formulas, because I mean, it's very likely that you'll ask them in a question, but you'll never be asked to apply them per se. You know, in hypothesis testing, that's not the way that they will ask you. The way that they will ask you, we'll cover, you know. So variances of B2 and B3, remember them, recall, I mean, you know, figure out your ways of doing it. And you know, that should be able to kind of cover this for you. By the way, and if this is something that you are a little concerned about, B1, remember that the only reason we didn't have B1 as an unknown here was because the first equation with respect to B1, the FOC, was in fact giving you B1 equals y bar minus B1, y bar minus B2 x2 bar minus B3 x3 bar, right? So this was B1, and hence B1 is not an unknown, right? Alright, so you will have the formulas for the variances of B1, B2 and B3 respectively. Please remember them. You will have been able to derive B1, B2 and B3 respectively. Go over this derivation, please spend some time on it. If you don't understand the Cramer's rule, spend some time on that. And yeah, that's about it. This kind of covers the crux of what the MLRM sort of chapter is about. Apart from this, there are a few, you know, adjustments to the R squared, R bar squared. I mean, so there's things like adjusted R squared, hypothesis testing, etc., which we'll be covering in the next few videos. That should kind of wrap up this chapter for you. And then we start on a very interesting topic, which is functional forms, because there, I mean, you know, you get all the possibilities of going all crazy, and there you kind of understand how powerful econometrics is as a tool for economics. So yeah, see you then. All right.